All right, we should be live. I don't know. You're going to have to tell me. Am I live? Is it happening? Okay. I don't know. Is the audio, it's all new gear, new camera, new audio. So you got to tell me if it's actually functioning. All right. It is live, according to Home. So I'll have to go for that. Hey, everyone. Welcome to the question show. Live and good loudness. Well, that's the key, right? Because I'm always too quiet. I'm always unintentionally doing an ASMR video. All right. So, welcome to the question show. For those of you who have no idea what it is that you have stumbled into, we are going to talk about space. And you're going to ask me all of your questions, and I have no idea what it's going to be about. And then I am just going to rattle off answers to the best of my ability. Now, thanks to the wonderful help of John Seffel, you can ask your questions in the YouTube chat, and then he will grab them and throw them into my database, and then I will see those questions. And I see your name. I see how many times we've answered your questions before in the question show. And I will try to get through as many of the questions as I can. We break this into two pieces. So there's the main show, which goes from now until about 6 o'clock. And that is the one that we edit down into the question show, the Q&A that you see just on the channel here. We make this unlisted after. And so if it's the trick is that if you ever want to watch one of these afterwards, just make sure that you've got, if you're subscribed and you get the notification bell. Oh, this is bad. Don't need that. Okay. Okay, I'm going to go to Do Not Disturb. Okay. There we go. Bad phone, bad. Right. So, and then at the 1 hour mark at 6 o'clock my time, we shift over into overtime, and then we go for longer. Typically, it's another hour. So this total show that you are looking at is about 2 hours long. And as I said, if you're subscribed and you click on the notification bell, you should get an email from YouTube. I don't know if this works, but telling you the location that Fraser is now live streaming. And then that's a permanent link to this episode. And so if you don't want to attend them on time, that's totally fine. The other thing that we do is whenever I release this to the patrons, I make the video live and I put a link to this live stream. And so if you subscribe to me on Patreon, if you follow me on Patreon, you don't have to give any money. You can just follow. It's free. But then you'll see the links to the live streams as well. So there's ways to get this information afterwards. All right. So go ahead and put your questions in. Just to sort of give you some ideas, I give emphasis to the people who've never had a question answered before. And so if I see somebody who's had I don't know, Visto, you've had 8 questions answered. But sometimes your questions are so good that I just can't help myself. Yeah, I'll give emphasis to the people who've never had a question answered. Second thing is just remember, I'm a journalist. I'm not a scientist. And so I do not have opinions about scientific things. I report. And so I can tell you the things that have happened, what people believe, the various competing theories, the technology, all that kind of stuff. But if you're asking for my opinion on the multiverse theory or the engine design of Starship, I have no opinion. That's Scott Manley's job and Sean Carroll, I guess. I run sort of a model in my mind of the questions we've answered fairly recently. And so if it's a question that we've had a million times before, I might just skip it. So don't be heartbroken if I don't get to your question. It's nothing personal. I'm trying to sort of craft the show in real time using your questions, trying to mix it up, trying to go for the stuff that I think is going to be most entertaining to the audience, that match the kinds of stuff that I know the answer to. And so now typically we'll let loose in the overtime part. And so if I didn't answer your question during the main show, it's possible I'll get to the overtime. So typically I answer about 10 to 12 questions in the main show, sort of depending on how much time I want to spend on the question. And then I'll answer like another 30, 40 questions in the overtime section. So there's a good chance that we'll get to your question on the second part. And it's a lot more kind of, it's loose. It's not quite as sort of constrained. So hopefully stick around. Enjoy overtime. Yeah, there you go. Sabina has a ton of opinions on that. Yeah, so if you want opinions, go get to Sabina Hassenfelder. She'll give you opinions all day, all night. I have none. All right. So now, the other thing, no, we'll talk about later. Okay. I'm going to start the recording. All right. Testing. Yeah. Okay. I see it. All right. Chad, here you go. Here's your colors. Here you go. All right. And I'm just going to jump right into it, and then I'll sort of record the intro after the fact. Okay. Yes, I am recording. Aaron Calhoun, what do you think about life being... Aaron Calhoun, what do you think about life being spread by panspermia? I'm just a journalist, not a scientist, so I have no opinion about whether or not life is being spread by panspermia, but scientists do have opinions about whether or not life is being spread by panspermia. And so the idea of panspermia is that you could take an asteroid and you could smash it into a planet. And then the debris from that asteroid strike would go into orbit and potentially even get escape and even go on an escape trajectory that would take it out into, say, a solar orbit. And then that debris, those rocks, could land on the atmosphere of another planet like Venus or Mars, and then enter the atmosphere and then land. And we see this. I mean, we find meteorites from Mars here on Earth. So we know that rocks can make the journey from world to world here inside the solar system. But the question is, can life join in on this journey? And so when those giant asteroids crash into Earth and they smash up all this debris, there's absolutely life getting dragged out into space. Dinosaurs are going into orbit when the asteroid strikes. And so potentially hardy microbes, nematodes, water bears, are inside these rocks, and they're protected from the radiation of space, and they can make the journey, and then they can land. And the crazy part is that, we know that the impact of an asteroid and then kicking up the debris is actually gentle enough that, we can see that the rocks have survived. They don't get immediately atomized. And so, in theory, life forms inside those rocks, which there's life inside all kinds of rocks here on Earth, can make it to orbit. And that when those rocks pass through the atmosphere, yeah, they can heat up on the outside, but they can be kept cool in the interior. And so, in theory, life can make every part of this journey. And so one of the big theories is that life is traveling from world to world throughout the solar system. And it's more likely that life would be going from the lighter worlds with the lower gravity to the worlds with more gravity. So it would be more likely that you would get life going from Mars to Earth than from Earth to Mars. And so this idea of panspermia is that life on Earth actually started from somewhere else, possibly Mars. And that's great. I mean, and every part of this theory has been looked at and considered and seems reasonable, but you're missing these big pieces, which is, was there ever life on Mars? And that we don't know the answer to. And so until we get like a proper sample return mission, or really human explorers on Mars with a really powerful laboratory that are, people like me say laboratory. All right, fine. And so when you get on Mars and you've got a sample return mission, or you've got a really powerful laboratory, then you're able to retrieve samples, look through them, search for life, and find out if there's life on Mars. And if you do find life on Mars, then you can search to find out, is there a common ancestor? And if there is a common ancestor, then you can figure out when life shifted from Mars to Earth, or vice versa. And there's like an even sort of bigger extension to this idea, which is that you could have life going from solar system to solar system. I mean, we saw Oumuamua passing through the solar system. We saw Comet Borisov. We know that there are tens of thousands of asteroids of all sizes that have gotten here from other solar systems, and they're just passing through the solar system right now. They have inevitably crashed onto Earth. And so then the question is, could life that was kicked up in one solar system be transported and survive the tens of millions of years that it would take inside an asteroid to reach a target destination? And the answer is, don't know. Maybe. Again, it's that question of Mars, but even more complicated. But I really love the idea that every world in the Milky Way that is inhabited by life is leaving this trail of debris, like a cometary tail behind it, that contains meteorites that contain life. And then other planets are passing through those tails, catching some of those meteorites. They're landing on their planet, and life is spreading from world to world. And it, one extreme possibility of this idea is that there really is only one common ancestor in the entire Milky Way, and that all life, that it's such a rare event that all life in the Milky Way is descended from this one planet that figured out life. Who knows? It's fun to speculate, but more data needed. Connor Arroyo, what Earth-based telescopes are you most looking forward to? So those of you who've watched this channel for a while know the big telescopes that I'm really looking forward to, but there's like two main telescopes that you should be keeping your eye on for the next couple of years. The first, of course, is the Vera Rubin Observatory. This is the telescope that is coming out, well, is almost complete, and we should be seeing first light at the end of this year. And the purpose of the Vera Rubin Observatory is to image the entire southern night sky every couple of nights. It's an enormous mirror. It has probably the largest digital camera that's ever been made, and it will take these really deep, really sensitive images of the entire sky. And then 3 days later, it'll come back and take another picture of it. And then 3 days later. And so what you're going to get is the ability to compare image after image after image. And so you'll get, say, 100 images over the course of a year of the same spot in the sky. And then you can find, you notice that an asteroid is moving through the field of view, or Planet 9 is moving through the field of view, or you see supernovas go off, or all kinds of things. And then the more exciting, the most exciting part are the anomalies, the things that we've never even thought of, things that have never been observed, the things that the universe was doing when we weren't looking. And Vera Rubin will give us those. And as soon as it comes online, like next, we're going to all wonder, like, when do we get one in the northern hemisphere? But we start with the southern. When do we get a space one? But Vera Rubin is going to be a total game changer. There's going to be like this constant stream of live data of all of the interesting things that Vera Rubin is finding. So like my plan is to bring together a bunch of astronomers, and then we'll just watch the data stream. And then as things are found that are interesting, we'll talk about what they are. Oh, it just found a supernova. Oh, it just found a type 1a supernova. Oh, it just found an asteroid. Oh, it just found Planet 9. And we'll be able to talk about those like in real time as these things are being discovered. And I'm really excited for that telescope. The other one that I'm really excited about is the European Extremely Large Telescope. And this is a 39-meter telescope that is being built in the Southern Hemisphere as well at the European Southern Observatories. Is it Paranal? Anyway, this is a 39-meter telescope that's being built in Chile, and it's ludicrously big. No, wait, it is overwhelming. No, it is very large. No, extremely large. So people always get a laugh out of the naming scheme that the European Southern Observatory gives their telescopes, right? They have the very large telescope. Now comes the extremely large telescope. They were planning to build the overwhelmingly large telescope, but that was canceled. So we get the extremely large, and that is just going to be a monster. And so some of the things, like, it's going to be able to do everything that, say, the Very Large Telescope can do. It's going to have a really powerful adaptive optic system. It's going to be able to see, it's going to be able to do spectroscopy. It's going to be able to image star systems. It's going to be able to detect Earth-sized planets orbiting around sun-like worlds directly. It'll be able to block the light from the star and to be able to image the faint planets that are nearby for a few close candidates. And like, that's a revolution to be able to do that and like be able to detect the atmosphere on those worlds. Now, it might not be as powerful as the upcoming Habitable Worlds Observatory, but it still is going to be such a powerful telescope compared to anything else we have, both on the ground and in space. And for quite a while, the most powerful telescope that humanity has available to it is going to be the Extremely Large Telescope. And that's coming out in 2027. And so we're just 3 years away from this monster telescope getting first light as well. Two really exciting, and that's just two. I mean, there's the Giant Magellan Telescope, it's a 30-meter telescope. There is the Square Kilometer Array, which is coming out, which is going to be it's going to revolutionize radio astronomy as well. So there are just a whole group of mega telescopes coming out in just the next couple of years that are going to change our understanding of the universe from the ground, and you don't have to go to space. Mind-bendingly grandiose telescope. JK Software, just found your channel about an hour ago. Follow-up question from last week. What would it take to send telescopes to the solar gravitational lens with the current technology? Welcome to the channel. Great question. So the solar gravitational lens, this is the place. It's about 500 to 1,000 astronomical units away from the sun, where the gravity of the sun becomes a natural telescope lens that allows you to magnify anything that's on the other side. And so you could use the solar gravitational lens with just like a 1 meter telescope, could be able to see a megapixel image of an Earth-sized world orbiting around a sun-like star. Like we could see mountains and forests and cities and all that kind of stuff. Oh, itchy nose. Okay. But 500 astronomical units away from the sun, that is far. Like that is the kinds of distances that the Voyagers are still struggling to reach, and they've been at it for like 50 years. And so you're going to need something a lot faster. Now, I've done an interview here on the channel with Dr. Slava Turyshev. He's the person who is proposing the solar gravitational lens, and he is also proposing the solution. And what he suggests is a solar sail, that you take a solar sail and you bring it really close to the sun, and you take advantage of this trick called the Olbers maneuver, where you get this gigantic acceleration when you're really close to the sun. The sun is accelerating the solar sail, and you can get it going really, really fast. And according to Dr. Turyshev, you should be able to reach the solar gravitational lens within, say, 20 years, which I know sounds like a long time, but you know, are you patient enough to wait for an image of an exoplanet that's that good? But there are a lot of other ideas, and like we're working on these all the time. There are a lot of other ideas, and of course, we're reporting on this at Universe Today all the time. There are mag sails that use the charged particles coming from the sun to accelerate to really high velocities. There are light sails where you take a laser and you point it at a solar sail and accelerate to enormous velocities. These are the ones that are proposing that you could go to, say, Proxima Centauri at 20% the speed of light. You could definitely get out to the solar gravitational lens if you wanted to. There are new kinds of fusion drives, fission, nuclear rockets. There's plenty of ideas. And so really it's going to be a matter of people being willing to test out and try these really new propulsion systems. And like these have value across everything, like faster ways to get to Mars, faster ways to get to the outer solar system. Could we get to Neptune and have it not take 20 years? What could we do it in 5 years, 3 years? So these new ideas for propulsion systems are really important, and they're going to just play a role in all of the kinds of space exploration that's planned in the future. And one of those, I hope, will be the solar gravitational lens. John Vital, does a supermassive black hole have a maximum size? If so, what happens if it exceeds it? No, supermassive black holes do not have a maximum size. You could feed a supermassive black hole all the matter in the universe, all the energy in the universe, all the dark matter in the universe, and it would be perfectly happy with that and ask for seconds. John Dopeker, what are your thoughts on the rumors that NASA forced Astrobotic to re-enter here on Earth, crashing on the moon because of the novel? That's crazy. I do not believe that. Like, it just sounds like conspiracy theory to me. Grave Spinner. With your position on the Fermi paradox, do you think that money spent on habitable planet searches should be best spent in other areas? Absolutely not. So, for those of you who don't know, my position on the Fermi paradox is that I think we're alone in the universe, that I don't see any evidence of any life out there, and I feel like we should have seen some. And so, either like we're the only life in the observable universe or the first life in the observable universe. And partly it's because like all the other solutions just sound so awful to me, so horrible that I don't even think about them. You know, the great filter. But does that mean that I think we should not search for habitable planet? Absolutely not. Like the whole point with science is you could have a hypothesis. My hypothesis is that we're alone in the universe, but you need to do science. You need to check. And like think about the consequences if we are the only intelligent life in the universe, or really the only life in the universe. You've got this gigantic observable universe, 100 billion stars in the Milky Way, 2 trillion galaxies in the universe, and the only place that life formed is in this one tiny rock in this one galaxy. And then here we are, we showed up, and we extracted all of these resources, and we came up with this amazing technology, but we failed to spread life into the cosmos. And then we go extinct, and then the octopuses don't have any coal to burn, and then the sun heats up the planet, and then life is gone from the Earth. And then that's that. And the universe had this chance for having life, and we blew it. And it was on our watch. It was our fault. And so I think that the step one is we do an exhaustive search to find out if we are truly alone in the universe. You know, that's just like my opinion, man. That's not like a scientific fact, and you should never just like rest on your opinion. You should go and do science to find out the truth, find out what nature really knows about how much life there is in the universe. And if we aren't alone, then great. Then the responsibility is not on us to make sure that life survives in the universe, that we'll let the aliens do it. It's not our problem. We can go back to doing what we do. But if we are alone, then wouldn't that suck if we had a shot and we didn't take it? And part of it is us not taking good care of this planet, about not maintaining Earth as the best place in the universe for life as we know it. And part of it about us developing our technology and getting off Earth and exploring and starting to push out into other star systems. I think we have a responsibility. I think that trees are better than rocks. And so I think the universe is made better by the presence of life. And so I think it's our responsibility to spread out into the universe if it turns out that it's alone. If it turns out that we're alone. And if we're not alone, then we'll be good neighbors. Promise. JK Video, your thoughts on why China is not participated? No. JK Video, your thoughts on why China is not invited to participate in NASA and or ESA projects. I'm not sure what the rules are with the European Space Agency, but with NASA, they have a regulation in US that says that China and the US are not allowed to work together on aerospace projects. Is it ITAR? Anyway, and this is sort of one face. This is one-sided. So this is the US saying that China is not able to participate. And that means that China can't send astronauts to the International Space Station. China can't supply parts to US rockets, things like that. And I'm sure there's various carve outs for different kinds of technology and using drones out at Cape Canaveral and things like that. But when it comes to the actual technology, China is not allowed to be part of it. But why does it exist? I mean, that's a political conversation. You're going to have to talk to Congress and find out exactly why they wrote those laws. And I'm not sure how well they extend to the European Space Agency. I'm pretty sure there are collaborations between the European Space Agency and China. And there's also one-on-one collaborations with China on a bunch of projects. I mean, China said they're planning on inviting international astronauts to their space station shortly. And you get a lot of collaboration with some of their scientific instruments and missions. So, for example, the FAST telescope, American astronomers and European astronomers use the 500-meter telescope in China all the time for research and a lot of other stuff. There's a lot of international collaborations on the science side. So, I think it's a fairly specific carve out on exactly what China is not allowed to supply. And, that seems to be, it's always less than ideal when people don't work together. And what you've got as a response from China is a gigantic homegrown rocket industry. They launch as many rockets in China as pretty much the rest of the world combined. I mean, they almost launch as many rockets as SpaceX does. They are working on, they have their own reusable space plane like the X-37B. They have their own, they're working on reusable booster rockets like the Falcon 9. There was a test like today where they tested out a reusable rocket booster prototype, but they've got a bigger version coming probably next year. They're going to try and actually launch to orbit, and they're working on their version of fully reusable two-stage rockets like Starship, but they look similar or they look different. And there's like dozens of companies in China that are doing this kind of thing. And so what you get when you exclude them is a completely homegrown, disconnected rocket industry. And I don't think it's a great thing. Like, I think you want to have more collaboration, more cooperation, things like the International Space Station, where you've got Russia and the US that were effectively enemies coming together to build a space station. And they're up there right now, peacefully doing science and being friends. And I think it's always really important to do that. And you're going to get this completely independent space exploration plans from China. They've been retrieving samples from the moon. Then they've got another sample return mission coming. They're building a new heavy lift rocket. They are building a new lunar lander. They're building a new crew capsule to both deliver astronauts to the Chinese space station as well as to carry astronauts to and from the moon. And their plan is in 2029, they're going to send humans to the moon. And NASA just slipped to 2026. And wouldn't it be great if there was like a base, wouldn't it be great if there was a research base on the moon that was staffed by scientists and astronauts from the entire planet, from every country, working in friendship? A man can dream. So I think partnership and collaboration and scientific community is always better than the alternative. But I understand there are politics and global diplomacy issues and saber rattling and all kinds of stuff that I don't think about. I don't make the laws. I just want everybody to get along. Noor Ahmed. Fraser, I have a question about astronomy communication itself. Has information about Noor Ahmed. Hey Fraser, I have a question about astronomy communication itself. Has information about space research become more truthful or more muddied now than perhaps 30 years ago? Now, 30 years is just before my time in doing astronomy communication. Like, I started 25 years ago, so I don't know what was happening. But I remember finding out about, say, comet Shoemaker-Levy 9 crashing into Jupiter. I remember Sojourner landing on Mars and watching all that. And that was just a couple of years before I got started. Kind of got me inspired to start. And back in the day, there was a much deeper trust in scientific institutions. So you had, like, out at Cape Canaveral, there were trucks for all of the major TV stations, and there was wall-to-wall coverage of rocket launches. And then over time, less and less people showed up and less trucks, and it, sometimes feels like a ghost town when you're out at Kennedy Space Center. And then, and you would get, say, at the the astronomical conventions, you would get people giving press conferences, and you have a bunch of press releases that would go out on the wire, and then people would pick them up and they would report on them. And the coverage was pretty in line with what was coming out of the astronomy conferences. And it was done by the mainstream media. And there were dedicated journalists who specialized at these big agencies. So, like, think about, say, Miles O'Brien, who used to be the space journalist at CNN, who's now found a great home over at PBS. Or think about Alan Boyle, who led the space coverage over at NBC or MSNBC. And so you've got, like, all of these traditional media, and then they are laying off their space journalists, and so they're making the science journalists do the space journal, and then they're laying off their science journalists, so they're making their weather journalists and their nature and their environmental reporters do these stories. And so they just don't understand all of the nuance and all of the details the way that the people who specialized and focused on it did. And at the same time, you've got the rise of smaller independent organizations like us, like Universe Today, like space.com, as well as people who are just doing direct reporting. I mean, think about, say, the Everyday Astronaut, or think about the folks at Dos Padre, or some of the other channels on YouTube that are specializing in these really detailed areas. You've got scientists who used to go through some, a public relations official to get their work out, are now just being able to connect with people directly. Look at Dr. Becky. Look at David Kipping with Cool Worlds Lab. Sabina Hassenfelder. You've got Brian Keating. Like, you've got a lot of people who are educated in this and are also going out to a direct audience and explaining the results and helping people understand what's going on. And so I don't think it's really simple. Like, on the one hand, the mainstream media has lost the ball and doesn't really do a great job. You've got a rise of clickbait and people just telling you and warning you and freaking you out about asteroids that are going to be coming relatively close to the Earth, and doing a sort of really bad job of explaining what are pretty mundane results in sort of terrifying terms. But on the other hand, you've got this really great specialized industry of space journalists. And so I think if I was to name people right now that I trust, and then compare that to the people that I would have trusted 25 years ago, there's probably 10 times more people who I think are really good at space journalism than back then. And so overall, the research is, or the reporting is way better. But also there's a lot of noise in the system. And I think it's going to become harder and harder for people to know which voices they can trust and which voices are just trying to get them to click on articles. And this is something that I've been really struggling with, which is how do we be a trusted source of news in this thing? Like, what I want is when you see us putting out a new story, you're like, oh, it's Universe Today. Okay, great. Then this is real, right? That's what I hope you see. And then when you see one of the videos on YouTube, then you're like, okay, great. I was waiting for Fraser to tell me what the scientific consensus is on this issue. And so I think things are going to get weird in the coming years. We see a lot of muddied information on just the web in general. We see a lot of people with access to grind sowing misinformation, trying to confuse people. And that didn't exist in the past. So you didn't get this disinformation that was coming out at the same degree. So it's going to be interesting. Find people that you trust and respect, and hang on to them for dear life. Was there a Lagrange question? Oh, I can't wait. Sid Vicious. I love Universe Today, all the work you do. I love the newsletter, videos you release almost daily, and all the great interviews you do. Is there a way to support your work? Patreon.com/Universe Today. That is the way. Where was the... Maybe human. Don't you think it's a bit presumptuous to think that we are the patient zero of life, considering the universe is so big? Exactly. Where is everybody? Let's look for them. Okay. All right, I see. Here's a question. Michael Bark. What is the volume of space encompassed by the effects of a Lagrange point? How big can we make the craft? Thank you for the Lagrange point question. Just made my day. So Lagrange points, of course, these are the 5 stable points around every 2 objects that are orbiting one another. Let me see again. So Lagrange points, these are the 5 stable points that you get when you have a very massive object orbiting an even more massive object. There are 5 Lagrange points between the Earth and the Sun, 5 between the Earth and the Moon, 5 between the Sun and Jupiter, and so on. Now, 3 of the Lagrange points, the ones that line up, L1, 2, and 3, are unstable. And so imagine them as like the tippy top of a mountain. And as long as you perch up at the top of the mountain, you're not going to need very much energy to remain at the top of that mountain. But as soon as you start to roll down the side of that mountain, you're going to need more and more energy to get yourself back up to the top of the mountain. And so all of the energy that you spend is pushing yourself back up onto the mountain, right? With the L4 and the L5 point, they are like the bottom of a valley, that once you get into the Lagrange point and you're in that area, it actually takes energy to get out of it again to go somewhere else. And so you're just going to end up in that place effectively forever. And you're asking, how big are they? Well, Lagrange points aren't points because everything is an ellipse. And so when you think about the Earth's orbit around the sun, it is not a perfect circle. It is an ellipse. The sun is farther from us sometimes. The sun is closer from us than sometimes. And so think instead of the Lagrange point as a Lagrange blob. Not only that, but you have the interactions of, say, the moon that's orbiting around it. So you have the interactions of Jupiter, which is pretty enormous, plus Saturn, plus all of that. And so it's constantly warping and changing the sizes and shapes of these Lagrange blobs. And that's why you can't just go and put a spacecraft perfectly at the Lagrange point and just hang there forever. The point is moving, the blob is shifting. You could average out all of the gravity of all the places in the solar system, and it now turns out that the Lagrange point is 100 kilometers to your left. And so you have to sort of keep yourself oriented as close as you can to the center. And with the L4 and the L5, they're actually these quite large regions that take up several degrees of the, say, the Earth's orbit around the sun, for example. And so things aren't stuck in this one point inside the L4 point. It's actually just this giant, chaotic, rolling orbit of objects that are moving around inside this zone. And the shape and the size of it just depends on all of the gravity of all of the objects that are interacting, as well as, the mass of the thing that you put in there. There's a lot of variables. And so, how big can you make the craft? Your spacecraft has to be of negligible mass compared to the smaller object. And so, for example, if you have the Earth and the sun, something that is of negligible mass to the Earth might be a asteroid that is several kilometers across. But if you wanted to have one that is orbiting around, say, the L4 point, L5 point of the moon and the Earth, now you have to have something that is smaller, something that is maybe hundreds of meters across. And so we see this distribution. Like when you go out to Jupiter's Lagrange points, you can see comets and Trojan objects and asteroids that are jumbled up in this area that are hundreds of kilometers across. And yet Earth's Lagrange points or sun Lagrange points hold stuff that's just a few kilometers across. And I don't think people have found any objects around trapped in the moon's Lagrange point around the Earth. So it all depends. Pete Martinez, do you think we'll see Artemis take off this year? No. The plan is for Artemis 2 has been pushed back to next year, 2025. is when we'll see it launch. Rogue Gaming, interstellar swarm mission. Instead of many probes sending a large signal together, what about spread to us from Proxima Centauri and reload? Rogue Gaming, interstellar swarm mission. Instead of sending many probes with a large signal together, what about spread out from us to Proxima Centauri and then relay the info? So, I mean, this idea comes up a lot. You know, if you're going to send a string of probes from us to Proxima Centauri, then the probes could relay the information all the way back along the chain, and you could get a much better bandwidth than individual probes that are attempting to send data like a few bits per week, or this swarm idea that I just did the interview with Marshall Eubanks about this, that the entire swarm acts like a one signal it's sending at the same time. So the problem, of course, is that you don't want to break the chain. You can't break the chain. And so the whole reason why you're sending thousands of these spacecraft is for redundancy, that a piece of interstellar debris could take out any one of them and it doesn't really matter. You know, you could lose 1%, 5%, 10%, it's fine. But if you've got these individual probes and they are designed to communicate with another probe, maybe there's some redundancy. They could skip one slot and get to the next one or the one after that. You get 2, 3, 4 probes get taken out in a line, and now the chain is broken, and now there's no communication to or from Proxima Centauri. And so this idea of using a swarm of small craft communicating in sync fixes a lot of problems in communication for really far distances. Just you should write a book about Lagrange points. I feel like I have. Have I not? Is this not my life's work, explaining Lagrange points? Save the planet. Fraser, do you know any plans or progress on an up-to-date space station to replace the current ISS? It seems that it should be of the utmost importance and the clock is ticking. So right now, the International Space Station is still operating fine and there's a ton of astronauts on board, but the plan is probably to retire the space station by the end of the decade. Now, people are saying that they're going to bring it down, 2028, maybe the 2030, but who knows? People may change their minds, find some funding, keep it going. But at some point, it's going to be time for the International Space Station to be crashed into the planet. Into the ocean graveyard of the Pacific? Anyway, harmlessly. And so what have you got left? You've got the Chinese space station, which is fairly new and is going to be operating probably for a couple of decades with additions and enhancements and new modules and new crew swaps. So that's going to be working in low Earth orbit. NASA is shifting its focus to the Deep Space Gateway. That is going to be their space station that is out in a orbit that sort of takes it close and far from the moon. And this is going to be testing out keeping humans alive in deep space. Would NASA love to have a space station in low Earth orbit and the Deep Space Gateway? Absolutely. But they don't get that kind of funding. And so they had to choose. And since the plan is to send humans to the moon, they're having to build technology that supports the plan. You've also got private space stations. And so there are plans to dock a private space station module to the International Space Station, and when the time is right, you may get parts of the space station detached into a new private station, and then the rest of it is deorbited. That's the plan right now. Now, there's a lot of really great ideas, and we report on them all the time about inflatable space stations and rotating space stations that would test out artificial gravity in space and various private space station ideas. But right now, there's nothing that is absolutely concrete that is for sure going to happen except for the Chinese space station and the Deep Space Gateway. John Dopker, what about reports of life is almost certain to exist on Venus? That's inconclusive. Scientists argue about whether or not that's actually life. You won't know until you actually send a probe into Venus to sample directly, to collect samples, to bring them home, which is, by the way, a NASA NIAC proposal that just came out. Jeffrey Prinko, can you be stationary in space and not moving? It's compared to what? So It's all relative. You have to ask yourself, are you moving compared to what? If you are stationary beside your friend, you're both floating in space, then compared to your friend, you are stationary. But compared to the Earth, you're orbiting around the Earth. So you always have to ask yourself, compared to what? Oh, KGS, do you know of any astronomy question to AI chatbots that always give the wrong answer? So when I play with AI chatbots, I give them the task of explaining the Big Bang, and so I say like explain the Big Bang to an elementary or high school student, and they always give the answer wrong, which is that they explain it as an explosion of space and time that's spreading off in all directions, and then I have to go like, well, didn't it happen everywhere? And like, oh yes, sorry, my apologies. So, I think most things that you ask it to, it introduces hallucinations and mistakes. Like I find it's useful to give you like a rough lay of the land, and so if you're like trying to understand some concept, then you can start to ask it questions and it can give you some answers, and then you can use that as the starting point for a deeper research. But if you're trusting ChatGPT to give you correct answers, yeah, you're not getting correct answers. It's cool though. I use ChatGPT like crazy. Just I would never let it write an article on Universe Today. I would never let it write a script for me for video. Like I'll let it translate a piece of text into English so I can understand the gist of it, or I will let it. Yeah, yeah. No, I'll let it do kind of like brute force work, but I would never let it write stuff. Hooded top. If all the scientists in the world came together and really worked on a faster interstellar travel method, would it not be better for us in the long run? Have you ever read Project Hail Mary? This is the new book by Andy Weir. You get that example where there is this existential crisis for planet Earth, and so they need to develop an interstellar mission ASAP, and so they do. And you get like just there's no limit to what people are able to do to accomplish this goal, and it's cool. It's great. The reality is that there is no great benefit to an interstellar mission for us today. Like, yes, we could get some scientific questions answered more quickly than we could, if we waited longer for the technology to come along. All we can do is satisfy our curiosity. Like that's the only thing that interstellar travel gives us is satisfying our curiosity about the universe. Can we get some pictures up close of Proxima Centauri? That would be cool, but it doesn't give us any practical value. And that's fine. Like that's curiosity, that's exploration. It's what humans do. So, in the long run, I don't think so. I think that this technology will be developed at the pace that it gets developed as people see the need. And although there are certain scientific questions that I would love to see the answers to, I'm patient. So. Robert Highmarsh. I realize every star is different, but how accurate is the Goldilocks zone relative to a star? So, the Goldilocks zone, the other term for this is the habitable zone. And this is a region around the star where, on the inner side of this habitable zone, water can't exist because the radiation is too strong and it will boil the water away on the surface of a planet. And on the outer part of that, liquid water can exist, that the average temperature on the planet is going to be frozen and you'll just have an ice ball. And then in between, there is the potential for liquid water on the surface of a world. But it is a really kind of mushy distinction. So here in the solar system, for example, the habitable zone around the sun extends from just inside the orbit of Venus, includes Earth, and goes out beyond the orbit of Mars. And so if the atmosphere of Venus was significantly different, if the composition of Mars, the size, the mass, and the atmosphere were significantly different, you could fine tune both Venus you could fine tune both Venus and Mars to get a habitable world kind of like Earth. Now, it might be a little warmer on Venus, really hard to sort of completely get rid of that excess heat, and it might be kind of chillier on Mars, but you could definitely get liquid water on the surface of both worlds. And so it's more about the composition of the planet and about the atmosphere of the world. And even now, astronomers are starting to come up with other scenarios, different kinds of atmospheres that totally change what the habitable zone is around the star. You look at, say, these Haitian worlds, these water worlds with a thick hydrogen atmosphere, and they could maintain a liquid water surface well out into the asteroid belt, almost all the way to Jupiter. They could have liquid water on the surface when they're orbiting around some rogue planet floating in space. And then, of course, you get the ice worlds, the ones that are going to have liquid water underneath a thick shell of ice, like Europa and Enceladus, and there could be life there. And so it is a really just rough sketch that just says, habitable zone here, let's look for planets there. It doesn't mean that anything that's in the habitable zone is going to be habitable, and it doesn't mean that things outside of the habitable zone won't be habitable. It's just a good place to start. Can there be liquid water on the surface of this world? Yes or no? Floater 81 floats. Why does Starship need fuel transfers to get to the surface of the moon, but Saturn V could do it all in one launch? Reusability. So with the Saturn V, look, at first, during the Apollo era, you had an enormous amount of budget that was put into the Apollo program. I think the entire Mercury, Gemini, Apollo program in inflation-adjusted dollars was like $350 billion. And when you compare that to the kind of budget that, say, the Artemis missions get, I think they get a couple of $1 billion a year. So 10 times as much funding went to the Apollo era. And so they could build these enormous rockets and spare no expense to put humans on the moon and show the Russians what we can do. And by we, I mean the Americans. So in the new era, where there's a fraction of the budget and there's new technology coming along that will allow you to reuse rockets. So the idea with Starship is the thing launches, flies to space. It's the fuel module, right? It's the propellant tank. And then other starships fly up to it, or maybe just one flies up to it 15 times, 18 times, transfers propellant. And then the human landing system flies up to the propellant system, transfers all the fuel, flies out to the moon, and then goes into orbit around the moon. And then every time astronauts arrive at the moon, they get into the lander, they go down to the moon, they come back up to their capsule, and then they fly home. And so now you don't have to have a separate lander. It's done. You've got this lander. Yeah, you may have to refuel it from time to time, but we're moving into this era of reusability and still trying to sort out. And so if you want to dispose of the whole system, yeah, you could redo the Saturn V. But if you want something that is more sustainable, reusable, that is moving towards this future infrastructure of humanity living in space, it's going to be this new model. Now, I agree that it is a risky, complicated there's all kinds of things that could go wrong, and we're all going to wait to see. And I know a lot of people are going to be really happy to watch this fail, and I don't think you should. I think that you want this to succeed. It's ambitious, but it will be great if it actually does work. The alternative is what the Chinese are doing. Their plan is to build 2 giant disposable rockets, and one is going to carry their crew capsule, one is going to carry their lander. They're both going to fly to the moon. They're going to meet up, and then the crew is going to get into the lunar lander, down to the surface, come back up, then fly home in the crew capsule. And then that both entire giant rockets will be destroyed, disposed of, and the lander will be destroyed, and all you'll be left with is that little crew capsule that lands back on Earth. And there's no reusability at all. The future, the big plan is that you've got the Deep Space Gateway, where is a home to astronauts for a long period of time, for weeks at a time, maybe months at a time. And there is the human landing system that is docking from the moon to the gateway, back down to the moon, and going back and forth and ferrying astronauts to and from the moon. And maybe there's some propellant factory down on the surface of the moon that's refilling it. And then you've got some ideally reusable, maybe it's Starship, that is flying from Earth to the moon, delivering astronauts, and every part of this system is being reused. And if they can pull that together, big if, then that's a dramatically new way of doing space exploration. And so I think it's important to look forward. Don't look back. Think about, what have we learned so far? What's possible? And build the kind of system that supports a long-term presence in space. Nicholas Somick, do you believe that time is infinite? Is the kind of question that I am unable to answer. I am just a journalist. I'm not a scientist. Okay, one more. David Friedman, hasn't the space race demonstrated international rivalry can also drive space exploration? I don't doubt that cooperation works too, but might some friendly competition not give us faster moon exploration? I think competition only gets you so far. I mean, we saw the international competition for sending the first satellite into space with Sputnik. We saw the first human to orbit the Earth with Yuri Gagarin. We saw the first docking, first spacewalk, and then we saw the first humans on the moon, and then nothing. Yeah, we saw the space shuttle, we saw the International Space Station, but it didn't, a lot of people feel like space exploration went into the doldrums at that point, because once the goal has been achieved of setting humans on the moon, then the need for this investment and this competition is over. When you compare that to historical investments in infrastructure, like when people figured out trains and were investing like many percent of their entire gross domestic product on building train infrastructure or fiber optics or cell networks, things that allow the sort of future use of this kind of resource, then it's around and it's here to stay, as opposed to just a race. So no, I don't think competition is like dirty fuel, and cooperation and just building infrastructure is a much cleaner fuel, in my opinion. And we're seeing it right now. Like, there's some stories coming out today about how people in Congress are starting to get a little nervous about how China is progressing in its going to the moon. And so that's what it took, was for people to start getting freaked out about another country getting to the moon first. But even though the US have already been to the moon, right? So it doesn't matter. No, I think that's a bad way to align your incentives. You've got to just figure out, what are we curious about? Where do we want to explore next? What are we curious about? Where do we want to explore next? What do we want our capabilities to become in the future? What infrastructure is important for us to have a more robust and creative economy down the road, and sustainable? And I think that's how you should approach it. And cooperation, trade. I mean, think about an iPhone. You've got bits and pieces that are coming together from this gigantic international network of parts and places and people to bring this one thing together. And that's couldn't be done without an international cooperation. So no, I think time after time, cooperation is way better than competition. Okay, so this ends the first portion of the episode. I got to record some administration trivia, and then we will move on to the overtime portion. So you've got about 5 minutes. Go to the bathroom, grab a snack, tell people you love them, and come back, and we will continue on with overtime, where I hammer through as many of the questions as I can as quickly as I can. Or maybe I'll just take an hour and rant about one topic. All right. Is life being spread by panspermia? What telescopes am I looking forward to? How big are the Lagrange points? Okay. Could life be spread through the universe by panspermia? What big ground-based telescopes am I looking forward to? And how big are the Lagrange points? All this and more in this week's question show. Welcome to the question show. Your questions, my answers, wherever you are across my channel. If a question pops into your brain, just write it down. I will gather them up and I will answer them here. All right, let's get into the questions. I'm sure you've noticed the Star Trek planetary name that appeared above my shoulder on the first question. Of course you did. How could you miss it? It was so obvious. You're like, what is that Star Trek planet doing over Fraser's shoulder? Well, here's why. We put up a different Star Trek planet name throughout this entire question show. You will watch all of the questions, and then you will choose carefully the one that you thought was the best or the best answer or the thing that you just enjoyed the most. And so we will then add up all of the votes and we will celebrate it the next week. You just put the word into the comments down below, and that's what we count up. So last week, the winning vote was smack dab. Can any extremophiles on Earth survive if we brought them to Mars? So thank you, everyone, for voting, telling us which you thought was the best. And we'll do this again this week. So just watch to the end to see the code words. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? It's about twice as long. You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to the recent newcomers. Shu Along, Steven Silber, Tim Somervale, Locutus of Zork, Intrepid Space Monkey, Ari Buggy, Arturus Cavalis, Alan J. Baden, Joseph, Bruce Nabozny, Abe Kingston, and Patrick F. Join the club at patreon.com/universetoday. All right, those are all the questions that we got this week. Thank you, everyone, for joining me for the live show, as well as everybody who asked questions in the YouTube comments. Now, we do this show every Monday at 5 p.m. Pacific time. So if you want to join in the live show, and it's twice as long, and you can ask questions and follow on questions, and I chat with the chat. We do this every Monday, 5 p.m. Pacific, here on the channel. All right, we'll see you next week. All right. I'm going to shamelessly self-promote something that I'm really excited about in a second. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Antonio Lofilara, David Giltonan, Dougie Stewart, Dustin Cable, George Hey Twyla, Jeremy Mattern, Jordan Young, Josh Schultz, Mark Ansis, Stephen Krasaki, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our patrons. All your support means the universe to us. So, those of you know, I write a weekly email newsletter here on my website. Let me do this again. Those of you who don't know, I write a weekly email newsletter that goes out to 70,000 people. And we just crossed that line, 70,000 people, which I'm really excited about. So I write every Friday, haven't missed it for hundreds and hundreds of weeks. And if you want to get it's a deep overview of all of the space news that's come out in the last week, not just the stuff that I talk about in Space Bites, but 30 to 40 stories that we're covering over at Universe Today, as well as other links to stories that we're not covering, but people who I really respect who are writing on the subject. You should definitely sign up to the newsletter. Go to universetoday.com/newsletter to sign up. And you can become the 70,000th and first person. All right. Thanks, and we'll see you next week. Okay. All right, so that's it for the admin. And let me start up the next audio, and then we'll get into overtime. 246. I think so. Noor Ahmed, I've been watching the channel's videos so much that I almost remember most of the patron supporter names now. Well, actually, so in the Space Bites we do it by order of when they signed up, and in the Question Show we do it by order of alphabetical, and so we've mixed it up. Hello, patrons. This is the overtime audio for Monday, January 22nd, 2024. Enjoy. All right, let's get into overtime. Reb Keith Carter, do you think that SpaceX should be using the technology at their launch sites that they plan on using on the moon to produce liquid hydrogen and oxygen? So the SpaceX rockets are fueled by methane. And right now, obviously, with natural gas, it's easy to just go to the store and buy yourself some methane. And that's what they do, is tankers show up with methane that are produced as part of the fuel making process out there, and they're able to tap into it. But one of the really interesting advantages of methane is that you can produce it using a chemical reaction out of the atmosphere. You've got solar panels, you're producing electricity, you're pulling carbon dioxide out of the air, you're using water, and you can actually produce methane just purely with electricity. And this has been proven, demonstrated in the lab. It can be done. Now, can it be done at scale? Musk has said that this is one of the long-term goals, that in fact, in theory, methane is a carbon neutral fuel if you make it yourself, right, as opposed to using natural gas reserves. So I think that's good. And absolutely, I mean, I think if the plan is to produce methane on the surface of Mars for a return trip home, you want to demonstrate that you're able to use that technology here on Earth, and you want to work through every single glitch and problem and situation, and then you're going to want to fine-tune it and improve it. And so can you imagine if SpaceX had giant factories that were making methane and they were really fine-tuning the process? Makes a ton of sense. And yet it's so easy to just have a tanker truck show up with more fuel, and you just pump it into your rocket. Away you go. Now, it makes sense to do this on Mars. I'm not sure what the process is going to be to make methane on the surface of the moon. You could definitely make, as you say, liquid hydrogen, liquid oxygen, but that's not what the Starship rockets are fueled by. They need methane. And so you need carbon for methane. And so I wonder how much carbon they're going to be able to get out of the regolith on the moon to be able to make fuel for themselves. So these are open questions, but yeah, in software development, there's a term called dog fooding, and the gist is like you should eat your own dog food, and that way you know that it's good quality. And in software, it's like if you're building a mail client, or if you're building like a web browser, you should use only that web browser. And that way you run across all of the bugs, all of the problems, all the issues, and then you are incentivized to fix it. And the same thing, if you're only making your own fuel, then you're incentivized to solve this problem. And that will have all kinds of ramifications for all kinds of technology. So I love the idea. Banana Boy 5793. Why can't we just build a rocket ship that flies like an airplane and send that to space? Because there's no air in space. And so airplanes need air both for lift on their wings as well as for to bring in oxygen as for the combustion of their fuel. So airplanes can only get you so high, and then they just don't work anymore. Visto 2D, could we dig down 3 kilometers to the ice on Mars equator with a well-aimed asteroid? Sure. Yeah, 3 kilometers? That would be a big asteroid. Like if, and this is about this discovery of fairly large ice reserves a few kilometers under the surface on Mars near the equator. And so I would probably just drill and not hammer it with an asteroid, because then you're going to make a mess. Kinchi, have you ever had your own NIAC ideas? Ideas are a dime a dozen. I mean, I got a million ideas, but like when you talk to the people who've had these NIAC grants, in some cases, they've applied year after year after year. Each time they've been rejected. So they've had to fine tune their ideas. They've had to figure out exactly what is the best possible idea before they actually get their grant. And and so always, like, I think of a million ideas, but I don't have the engineering capability to actually pull them off. I don't have the scientific capability to know what all the problems are. So, and that's fine, right? Like, I have a job. I have a job that I really enjoy, being a journalist, and I'll let other people. I get to talk to them and talk about their ideas. And, obviously, like, the cool thing about what I do, or at least the thing that I'm good at, is that I am exposed to so much information that I'm able to help people make connections. And so I'll be interviewing somebody about some piece of research, and then I'll ask them a question about this other piece of research over there, and they didn't even know about it. And then I can, after the interview, I will send them the paper, and then hopefully that can inform their thinking. I haven't had anybody get back to me and say, hey, that idea you talked about, I've written a paper on that. I'm still waiting for that. That'll be pretty cool. Maybe someone will make me a publisher on that. But yeah, no. So, like, ideas are a dime a dozen. It's implementation is what matters. JH, roughly how many sun-like stars are within 100 light years of Earth? About 50,000, give or take. ASCII, what happened to the methane on Mars that was being discovered, being emitted periodically? Any news? Nobody talks about it anymore. Yeah, there really hasn't been any new news on this. So this is an example of the kind of thing that was quite exciting for a while and is just too inconclusive, and nobody's able to be sure what it was. And yeah, I haven't heard any additional information about that. Rich M, when do you think humans will live at Mars for real with bases and stationary houses, etc.? I think that we're going to have a permanent Martian science base probably by 2045, 2050. I'd say by 2050, we will have humans going to and from Mars. I don't think we're going to have humans like live on Mars ever. Like, maybe, like, never say never, like maybe hundreds of years from now. But Mars is awful, and it's no place to live. It's a place to study. It's a place to endure, in kind of the way Antarctica is. Like, nobody wants to live in Antarctica. People want to go to Antarctica because they have science to do, but they are kept alive by an enormous amount of technology and infrastructure and expense. And Mars is going to be like that, but times 1,000. And so every human being that goes to Mars is costing Earth billions of dollars, and they want to get the science done, and they're going to want to bring them home. And I know that's what you don't want to hear, but that's that so far. And there's, this is I'm going to be interviewing Zach and Kelly Wienersmith tomorrow about their book, and their book is just like, it's the dream killer. It's crushing, but it's great. I really like the book. Travers Sampson. Fraser, could the reason why we don't see life throughout the universe be that most planets that can sustain life are not suitable for a spacefaring civilization, for example? Like, as soon as, like, life finds a way. And so as soon as you have life on a world, and there's some kind of evolutionary pressure that is working on it, and you've got limited energy and limited resources, then it is going to be evolving in this environment to try to gain more of those resources. And we don't know if intelligence, for example, is sort of on this inevitable path, but you can see the rise in complexity of life over time on Earth as more and more complicated life forms are able to do more interesting things. In the beginning, you just had plants that sat at the bottom of the ocean and collected nutrients that hit them. And then later on, you had things that could move around and eat things, and that was an advancement. And then you had things that could live on land and things that could live in the sky, and obviously, like, having intelligence, we are the masters of this planet. And all it took was a brain that was 3 times more neurons than a chimpanzee. And so, we don't know what's possible in all the different worlds, but if you run the experiment millions, billions of times in all these different worlds, you should get some examples of intelligent life. We know it worked here. It should happen in other places too. And yet we don't see any examples of intelligent life out there, which is why I think that we're alone. But there's other answers to try and explain it. That is the Fermi paradox. Oh, that's a problem. So I'm just sending chat a message here. Okay. Edward Leonard, is there a non-mass particle that doesn't travel at the speed of light in a vacuum? A non-mass particle. No, so like radio, gamma, X-ray, photons, they're all the same thing. They're just photons, and photons travel at the speed of light. Edward Teach, can JWST see further inside any planet? Will there be any technology in the future that can see inside a planet? So the way you see inside a planet is with seismology. We do that here on Earth. You've got seismographs that are these really sensitive instruments that can detect any kind of vibrations coming from the inside of the planet. And then you can detect those motions, and you can detect earthquakes moving through the planet, and that allows you to kind of map out the shape of the different layers inside the planet. They can do that with the sun, so they can actually look at ripples on the surface of the sun and use that to map out the interior of the sun. So you could do that with planets. Now, I don't know if you can observe a planet and detect seismographic effects from space, for example. Could you have, is there like a space base? Like I know there's stuff that detect the movements of the plates and various very sensitive height changes of stuff. But I wonder if you could actually use that. But no, you really can't see inside a planet with a telescope. Lila the dog, why do we have photos of distant planets, galaxies that are amazing quality, but the photo of the Uranus web just captures isn't so good? And it's in our solar system because a galaxy is like 100,000 light years across, contains 100 billion stars, each of which is as bright as, an average star here in the Milky Way. They are enormous. Uranus is a tiny planet compared to a star, and it produces no light. It is just reflecting the light from the sun, that it is pretty far away, and so it doesn't reflect a lot of light. And so it's just, Uranus is small, galaxies are big, and they're shining with their own intrinsic light. Goosetronics, thanks for making all these science videos. Could matter from a neutron star get flung out into outer space if it collided with another neutron star or possibly a black hole? Yes. So when a neutron star collides with a black hole or a neutron star, then you get a debris cloud that expands. And this was the kilonova. And in fact, it turns out that this debris is the source of a lot of the heavier elements that we find here on Earth. Like, it's likely that gold and plutonium and things like that were formed through the collision of neutron stars. John Burr, is it possible that different parts of the universe are expanding at different rates? I mean, it's always possible, but so like one of the main assumptions that astronomers make is that we're not in any place that's special, that we are in an average part of the universe looking at average random collection of galaxies around us, and they're doing the kind of thing that you would see if you went to any place in the universe. And they all appear to be moving in all directions at a very sort of smooth, similar speed. There's a couple of anomalies, but all the measurements that we get. Now, there could be stuff that's going on that is over the observable universe, that, that's over the horizon that we can't see, that could be acting completely differently. But it's, we have no observational evidence that this is happening. From what we can tell, everything's expanding at the same speed. Copper core, following up to the black hole question, didn't someone say that if you took all of the mass and energy of the universe, that the event horizon would be roughly the size of the universe? Yes, if you took all of the mass and energy, dark matter, and put it into a black hole, you would end up with a black hole with an event horizon that is the size of the observable universe. And you're about to wonder, does this mean that we are living in a black hole? And the answer is probably not. Well, some people think so because of that coincidence. It's just a coincidence. Sailor Sea Sailor, any chance that speeds that cosmic ray particles travel at somehow affects space-time? Could the dark matter we see somehow be echoes of those heavier particles traveling at riding high speeds? I don't really understand the question. An interesting thing is cosmic rays are traveling at really close to the speed of light. And when they strike the Earth's atmosphere, because they are experiencing time dilation, they survive longer than they should. And so normally you would expect a cosmic ray as it struck the atmosphere to hit an atmospheric particle and be decayed really quickly. But because it's moving so fast, it experienced time dilation. And in fact, we have detectors here on Earth that are able to detect the showers of particles coming from these cosmic rays as they strike the Earth. So it's not the cosmic rays, it's the particles that are generated when they strike the atmosphere. They shouldn't reach the ground, but because they're going so fast, from their perspective, they have longer to live. And so they actually do hit the ground, which is amazing. But I don't really understand how they could be the cause of dark matter. The problem is that whatever dark matter is, if it is a particle, it has to be slow moving. Erkan Mars, in your opinion, will solar sails ever become a reality? Absolutely. I mean, I think we're getting more excitement about solar sails now than we've ever had. The Japanese had their solar sail. The Planetary Society launched their solar sail. There was an attempt to put a solar sail mission on Artemis 1, but it failed. But I'm seeing tons and tons of solar sail proposals all the time, and we're reporting on them all the time for Universe Today. Paul Davis, how long will Saturn's rings last? We don't know. I mean, one of the big questions was always, are Saturn's rings young or old? It really appears now that Saturn's rings are fairly young, and they might not last more than a few 100 million years from now. But this is one of those things that astronomers argue about. Pete Martinez, is there any data about astronauts being under the influence while taking off? There is no data for that. I'm sure the Russians are smuggling vodka up to the International Space Station somehow, or the Americans. Who knows? I'm sure somebody has been drunk in space, but I doubt anybody would take the risk of being under the influence during the launch. I mean, you want all your faculties in control at that point. But when you're up in space and everything's safe and you're just having a party with your friends, yeah, who knows? Maybe they have a still up there. Plutonium obtusiangulum. Should we do a modern version of the Apollo-Soyuz mission joining with China? Yeah, I think so. I think that cooperation is better than competition, and we should have some kind of cooperation between China and other nations. D-suits. Where would the Lagrange points be between galaxies with and without dark matter? Well, I mean, the problem is that for Lagrange points, you need two objects, one with a lot of mass, one with less mass. And so you could get a Lagrange point between a galaxy and a dwarf galaxy that's orbiting around it. And the Lagrange points would change if the galaxy had dark matter and if it didn't have dark matter. I mean, you would have 10 times the mass. But then where the dwarf galaxy would be orbiting. So, someone could calculate all this, not me. Bob Hoppeldorf, can Starship really survive at 0.2c? RAS can cause problems on fairly large, well-shielded probes. Relativistic travel makes this even worse. I don't get how any of these probes survive decades. I mean, what you're saying is a common concern that has been raised many, many times, and the people who have done this, who are proposing these missions, have done the math, and they believe that a probe can survive the flight and not be destroyed. That space is big, and the kind of particles that can actually take out a probe are very few and far between. It should be fine. But we're going to have to see reality. And so we will find out fairly soon as we build gigantic space-based lasers and start accelerating spacecraft to relativistic velocities. Rocky Giuliani, Fraser, complete unscientific, absurd question here. Imagine people working on an area on Mars without spacesuits. How could they manage keeping the atmosphere within a certain parameter? I mean, they would have to have some kind of atmospheric pump that is blasting atmosphere at them with so much pressure that they're able to breathe while the atmosphere is being siphoned away to the rest of Mars. I mean, literally, you're going to be replenishing the atmosphere on Mars. But like maybe if you're like really close to where the pumps are blasting out air, you can survive for a little bit. But even that sounds tricky. It looks an interesting thought experiment. You can imagine another possibility, like they're at the bottom of a ravine and you're pumping in some kind of heavier gas, like carbon dioxide, or maybe what's it? Hexafluorine. It's like something that's really heavy, and then it will settle around them, and then they would still need a way to breathe, but they wouldn't necessarily need a spacesuit. But I don't know if you can even get the kind of atmospheric pressure that you'd be looking at. Love you all. Are magnetars formed from neutron star collisions? No, magnetars are neutron stars. And why a neutron star can get this gigantic magnetic field, we don't really know. But it probably has something to do with the star that dies in the supernova explosion being in some kind of binary pair relationship with another star. And so when the star dies, becomes a neutron star, it is interacting with material from the binary star, the companion, and that sort of winds up its magnetic field. But this is still an unsolved question. Stephen Nard, is a black hole two-dimensional or spherical? It's driving me nuts. It's spherical. Like one step before a black hole is a neutron star. So like imagine a neutron star and think about like the escape velocity in a neutron star. Like you have to be going like almost the speed of light to be able to escape from a neutron star. And it is this ball in space. And then you add a little more mass, and now it's a little more massive. And now the escape velocity to get off of this neutron star plus plus is faster than the speed of light. And now you've made a black hole. Stephen Collins, how much is a snowball Earth-like ice world that we're looking for life at now? So, I mean, snowball Earth, this was a time in Earth's early history where the entire planet was completely covered in ice, like glaciers. I mean, there was probably liquid water around the equators, but most of the planet was covered in snow and ice. And I mean, we don't have the capability to identify. Like, if you find we can't even directly image an Earth-sized world orbiting around a sun-like star, not to mention being able to tell whether or not the planet is covered in ice or whether the planet is covered in water or any of that. Like, we could find potentially water worlds around red dwarf stars, but we haven't found the Earth-sized world. So we need either the extremely large telescope to be able to do this, which I talked about earlier in this episode, or we need the Habitable World Observatory. It's going to be coming out in the 2040s. And then after that, maybe we'll start to get a sense of which of these are ice worlds, snowball Earths, and which are water worlds, and which are rocky worlds, and which are industrial planets, the heart of the galactic empire. Bobby Mons, what causes the hexagon shape at Saturn's North Pole? Is it an octagon? Yeah, I mean, you get these hexagonal storms on both Jupiter and Saturn, and this is a result from fluid dynamics. There was this really cool, there's Science World in Vancouver, and they had this big table that you could spin, and there was a fluid inside of it with like these little shiny particles. I mean, maybe you've tried this before, and as you spin it up, you get these very similar kind of hexagonal patterns showing up in it. And I forget exactly why it's a hexagon, but it's, you large amounts of fluid moving, you get these kinds of shapes, and the atmospheres of planets are kind of like a fluid. I think we have some version of it. We have these polar vortices on Earth, but because we have land masses, they get broken up and they don't get into these really nice hexagonal shapes. But they're the kind of the same thing, which is storms that are busting around the poles of the giant planets. FEP, FTCP. Fraser, do you consider that the Neptune color episode an example of bad science communication by NASA, given that they said that the blue color was enhanced but didn't release a true color pick? No. I think, like, NASA isn't this one monolithic thing with someone at the head of it going like, this is what we're all going to do. NASA is a collection of multiple research agencies, the Jet Propulsion Lab, the Goddard Space Flight Center. You've got Ames and the Kennedy Space Center and the Johnson Space Center. Each one of those is led by a person. And then each one of the space missions, whether it's Artemis or whether it's Curiosity or Perseverance or the Voyagers, is led by a person or a team. And then there's different instruments on board each one of these instruments, and they're led by a person or a team. And so it's just, at some point, somebody took pictures, the raw data of the images from Voyager, and they processed them and they stretched them to be able to look for the information that they were looking for, which was the clouds. And NASA said, can we show those to people? And they were like, yeah, whatever. I don't care. I'm here for the science. And so NASA's like, okay, great. Hey, everybody, here's the pictures that we got from Voyager. And it's just like everybody's busy and everybody's working on things, and nobody's like, well, what if, is this really the color that you would see if you're looking at it with your own eyeballs? A lot of the time, scientists look at images in black and white. They look at raw spectroscopy. They look at just the raw data, and they just don't care about colors and how pretty their pictures look. They're thinking about the science. The whole process of communicating with the public and getting people enthusiastic about this stuff, that's like a completely separate world. And the people who are doing that work aren't necessarily scientists. So, there are plenty, and there are plenty of examples. Like, every single picture that you look at from the Hubble Space Telescope is false color, right? Hubble uses multiple filters to image objects, and then somebody assigns the different filters, different colors to produce the images that you see. James Webb Space Telescope is taking images in multiple wavelengths of infrared. Like, your eye can't even see it. And so, of course, the thing you see in the picture from James Webb is nothing like what you would see if you could see it with your own eyes. You might not even be able to see it. And so, the underlying data are there, that there really are infrared signals of different wavelengths in different locations in the field of view. There really are storms in those places around Neptune. And the scientists are focused on answering scientific questions about it. And I don't care, I think, is how I feel. There's people who feel really upset that what we see of pictures of space are not what you would really see with your own eyes. But every picture of space you can't see with your own eyes. That when you look at a picture of a nebula, it is being exposed over minutes, days, weeks, and you only get those images through long exposures. Your eyes can't do long exposures. No amount of hovering in space, staring at the Orion Nebula from 20 light years away is going to get you a fraction of what you see in the pictures taken by the Hubble Space Telescope. That your eyes, your meat cameras, are just ditching photons within just a few seconds. And they're never going to build up this really cool image of what you see. That it's only when you take an image in one wavelength, you take an image in another wavelength, the one that shows you the rogue planets floating around inside the Orion Nebula from James Webb. And then someone goes, hey, maybe we should make a picture so other people can look at it. And scientists like, whatever, I don't care, right? It's not my problem. We'll let Judy Schmidt do that. Is then people get a chance to enjoy this stuff. And like the reality is far more fascinating than what you were hoping was true. The reality is that it's very complicated, and there's dozens of filter wheels on space telescopes, and astronomers get to pick and choose what they want. And different wavelengths are good for different things, and different exposures are good for different things. You've got a huge pipeline of scientific instruments that you can use on the telescope to be able to analyze the thing. Do you want the coronagraph or do you not want the coronagraph? Do you want this grism or not? These are all things that the scientist can use, the astronomer can use to analyze the image. And I think that's what's important. So I would rather just explain patiently, as often as is required, how astronomical images get made. And if people get upset about it, I think, they will eventually appreciate the depth and the wonder of what's happening and have a better understanding and appreciation. Like, get a telescope, take pictures of space, you will get it. You will understand exactly what's going on here. And if not, then let me explain it to you. Sid Vicious, I've heard some people that are not into astronomy say, what's so special about landing on the moon now that we did it several years ago, 50 years ago? What answer would you give to them? Humans explore. We're curious. Like, what are we going to not explore? Like, that's what's next. Space is the next place for us to go. The moon is close. Let's go there. Asteroids, Mars. It's what we do. So I don't think it really needs an answer. It's like, why are you climbing that mountain? Because it's there. Excalibur's engineering. Would things at the L4, L5 collide eventually? I know that many craft can orbit the L2. Yeah, they do collide occasionally and crunch into other things. But I mean, the space is gigantic. There are as many objects in Jupiter's Trojan belts, the L4 and the L5, as there are in the asteroid belts. So literally the solar system has two asteroid belts. One in between the orbits of Mars and Jupiter, and then one in the same orbit as Jupiter. They're gigantic. There are tens of thousands, millions of objects in Jupiter's Trojan regions, and they are getting up to all kinds of shenanigans. John Sostrom, with researchers discovering new quark math and uses, what is the possibility there might eventually be discovery that allows for apparent faster than light speed? I hadn't heard about this quark math, but what is the possibility? I mean, right now, traveling faster than the speed of light violates the laws of physics as we understand them. Maybe we're going to understand new laws of physics, and that will enable faster than light travel. But if faster than light travel is possible, then it makes the Fermi paradox even weirder. Like if aliens can travel faster than the speed of light, then they should be everywhere, and they should absolutely be here. So why don't we see them? Maybe human. To be honest, how much more science can the ISS realistically do that hasn't been done in the last 30 years already? There is an enormous, bottomless amount of science that needs to be done in space for us to understand what it's going to take to live in space. 3D manufacturing objects in space, growing food in space, closed environments to be able to understand what kinds of requirements that we have for long-term habitation in space, how materials are going to form and behave in space. Like, the list goes on. There is every supply mission that goes up the International Space Station is filled with science instruments and experiments. The astronauts have been doing science experiments full time for, as you say, for not 30 years, but for more than 20 years. Um, and the list is bottomless. In fact, there's such a demand for this that now there are science experiments that are done on suborbital flights, like on the Virgin Galactic flight and the Blue Origin flight, and they're done on balloons. And there's sounding rockets where people will do experiments to get just a few seconds of microgravity to test out some idea. How do things grow? What happens to the circulatory system, to astronauts in space? Like it just goes on and on and on. No, there are 10 times, 100 times, 1,000 times as many experiments waiting to be done on the space station as have been done already. John Vitale, can electromagnetic fields be used to assist in artificial gravity? Not that I know of. I mean, nothing provides gravity except for gravity. And if you had an electromagnetic field, like maybe you had like magnetic boots that kept your feet stuck on the ground, but that's not going to help with the lack of gravity across the rest of your body. Nope, you need artificial gravity, or real gravity would be great. Gitmo Holiday, what is your opinion about inflatable space stations? I think it's a great idea. So there's a new inflatable space station that is coming out of Sierra Space, and they've done a bunch of tests, and they're moving towards building a final prototype of this. And I love the idea that you fit this entire space station into a rocket fairing, ideally a 5-meter rocket fairing, but boy, would it be great to put it inside, say, a Starship. And then you launch the thing, and then the thing just completely inflates, and it's done. You've got your space station all in one launch. You don't have to do all this assembly, whatever. But you can, right? Then you dock 2 of them together, and they're gigantic. And just like a couple of launches could give you the same internal volume as the International Space Station for a fraction of the price. Resbum, what is the latest credible info that you've heard about Planet Nine? There's no new info. We're going to have to wait for the Vera Rubin Observatory to be able to find Planet Nine. If Vera Rubin can't find Planet Nine, then there's a problem for that theory because it should be found. J. Passer, is it easier to transform Mars or the moon for human habitation? I mean, I don't know what you mean by transform, like terraform. I would say terraforming the moon is easier than terraforming Mars. I know that sounds super weird, but if you were able to put a bunch of gas, atmosphere onto the moon, you could make it habitable and it would last for about 10,000 years. Like if you could add 1 Earth's pressure onto the moon, and it's close, so we could just like maybe crash a bunch of asteroids into it, keep the gas on the planet. You can make it habitable, and I love that idea because then it's the same distance from the sun, just like the Earth is, and so you can get the same amount of energy. It's going to get the same warmth. It is going to take 28 days to turn one sun on its axis compared to the sun's. You're going to have 2 weeks of sunlight and 2 weeks of cold. That'll be a problem. Maybe you could spin it up as well while you're at it. But no, I actually think the idea of terraforming the moon is a pretty cool idea. And then it's right over there. Mars is far. Jeremy Galloway, Fraser, what are your thoughts on New Glenn launching? Did New Glenn launch? That's exciting. Did it not launch? That's not surprising. Hopefully, like you want competition in spaceflight. Like having SpaceX run away with the entire U.S. launch market is a bad idea because then it's a monopoly, and monopolies are always bad. I don't care what the companies are. Monopoly's bad. So you want Blue Origin to be able to launch rockets. You've got competition so that you've got options and choices. And so the more rocket companies that can compete with one another and create this vibrant launch market, the better. KGS, hey Fraser, sorry if you guys already made an episode or someone already asked, but what's the winner of the Fraser Award 2023? Is that like a version of the Everyday Astronaut Awards? I don't even know what he did. didn't sort of follow too closely what Tim did to award those. Was it like his favorite stuff for the year? It's a good idea though. I don't want to steal Tim's idea, so just go to see Tim's awards. Maybe I can propose an award that's the Fraser Cain Award for Tim's ceremony. Maybe we'll do that. D-Suits, who came up with the news that JWST will find proof of alien life this year, and how will they discern that magma ocean from water ocean? Any preprints? So who came up with? So it was a paper about K18b, and they had a like 1 sigma detection of dimethyl sulfide, I think, which is a chemical that is only produced by life on Earth, but a 1 sigma detection is very low. And so the chances of it being true are, it's not super duper established the way scientists would like. But even it is, there's no reason to think that there couldn't be a non-biological way that gas could be produced in the atmosphere. Like maybe it's farting bacteria on Earth, but it could be farting rocks on this planet. And as I said in that story, like, you could explain the gases that you're detecting in the atmosphere of K218b with lava across the whole surface of the planet. So more research is necessary. Like more time with JWST scanning the planet will give you more answers. John Dopeker, could Jupiter in theory be mined for gas like Bespin in Star Wars? Yeah, you could mine. So there's a couple of ideas to mine Jupiter, and they're pretty bonkers. So the first thing is you do like some kind of scoop. Like as you're orbiting around Jupiter, you fall down towards Jupiter, and then you have some kind of magnetic scoop that is slurping up hydrogen and from the upper atmosphere of Jupiter. And then you're using that to power your fusion drive. And then you are then sort of escaping again from the gravity. You're going fast, so you don't need a ton of energy to be able to get back into orbit around Jupiter. And then you send your hydrogen off to some other place, and then you do it again. The other idea, and this is bonkers, is that you take a fusion drive, but it's like a tube, and you drop it down into Jupiter, and then it is sucking in hydrogen from Jupiter, and then it is using it for fusion. And so the thing is kind of floating in the upper atmosphere of Jupiter like a balloon, but also it has a fusion drive on the bottom of it, so that it's a Bussard candle, I think it's called, and then it is like maintaining and hovering in space. And then it is also slurping up hydrogen and blasting it off into space. Maybe it's making pellets on board that are then sending those off to some spacecraft that's in orbit, catching it, and then you use it. But like that is all hundreds of years from now. Float 81 floats. Is there an upper limit? How fast a spacecraft could accelerate to using the same strategy as the Parker Solar Probe? Yeah, so the Parker Solar Probe is accelerating. It's actually changing its orbit using flybys of other planets, gravitational assists. But the Voyager spacecraft used gravitational assists, New Horizons. Like, it's a way to accelerate your spacecraft. There is a limit. The limit is you leave the solar system, and now you just can't get back to do another gravitational assist. And that's, tens of kilometers per second compared to the sun. Michael Burke, regarding the theist theory of the origin of the moon, isn't that a very improbable set of circumstances that formed the moon without knocking the Earth out of orbit? I mean, who knows what's probable and improbable? We don't know. We only have one example of a planet with a large moon here in the solar system, and no exomoons have ever been detected. On that note, I'm going to be interviewing David Kipping in a few days about exomoons, so stay tuned on that, and maybe we'll talk about that. So we don't know. We don't know. Like, is this a common thing that happens? Do you get large moons orbiting around terrestrial planets or not? There was a paper that we covered on Universe Today about a week ago. I think the title was like "Large Planets Don't Necessarily Mean Large Moons." And they were questioning the likelihood of a large moon around a large terrestrial exoplanet, or even around large gas giants. So more data is necessary. More observations. Canon right. I've always wondered, if a star that's going to become a black hole has the same gravity as the star, then how can we see the light from the star in the first place, if that makes any sense? Sure. So, like, here on Earth, the planet has the density of like rock. If water is 1 gram per cubic centimeter, I think the density of Earth is like 5.5 grams per cubic centimeter. So it's not quite metal, but it's more dense than rock. And so that creates, when you measure the size of the Earth, then the gravity, the acceleration that's needed to get away from the surface of the Earth is 9.8 meters per second squared. But if Earth was smaller, but still had the same amount of mass, that means its density would be higher. So maybe its density would be double. Maybe its density would be 10 grams per cubic centimeter. And then the acceleration that you would be required to get off of planet Earth would go up. And I haven't done the math, but like let's imagine that I did do the math and the number ended up being 20. So you would need 20 meters per second squared to be able to accelerate off of planet Earth and get off into space. And then let's imagine that instead you had the entire, like the gravity on the surface of the sun is 10 times the escape velocity of what you need to get off Earth. So you need like 100 meters per second squared to get off of the surface of the sun. And that, like, light can do that all day long, no problem. Light can get off the sun. In fact, particles can get off the sun when they're energetic. But if you compressed the sun down, then that escape velocity is going to go up and up and up and up and up. And eventually, you make the sun so small that the escape velocity crosses the speed of light, that the speed you need to be going is faster than the speed of light, and you now made a black hole. Does that help? So stars are too big and fat and fluffy so that their light is able to escape. If they were smaller and denser, then light couldn't escape. Cruise Littlemore, just your opinion. What's the point of finding out more of the universe? Isn't it pointless? All right, you just invited a rant. So here we go. First, like, what is the point of anything, man? Right? So let's imagine that I gave you an envelope, and in that envelope was an answer to whether or not there's aliens in the universe. Would you open it? I would. I want to know the answer. I want to know if we're alone in the universe or not. I'm curious about whether or not. Well, we don't get the envelope. We have to do this the hard way, which is that we have to check. We have to we have to build powerful telescopes. We have to put them in space, and we have to look. If I could give you an envelope that told you where the universe came from, would you open it to find out? If I told you what the ultimate destiny of the universe is going to be, would you open that envelope? Imagine I keep handing you envelopes with answers to profound questions inside. Well, that's curiosity. And that's what we have. We have curiosity. And we don't know what of the things we're curious are going to become profound and are going to help us in a practical sense. When people invented lasers, they didn't think about all of the ways that lasers are going to get used. When people were mucking around with silicon and various kinds of semiconductors, trying to figure out what these weird materials can do, they weren't planning the chip revolution that allows us to have these conversations through the internet. You just explore. You're just curious about your surrounding, and you just explore. And we don't know what it turns out to. So what is the point? The point is to satisfy our curiosity. Why are we curious? I don't know. We evolved that way. That's just how we roll. So, what is the point of anything? Just because we're curious. And that's good enough reason. ST, many people comment about the crazy amounts of money spent on space exploration. It would be great to understand and hear about how some of those programs can and do assist us on Earth. There's plenty of conversations, lots of reports sent by NASA that say, like, here's the incredible return on investment that you get from investment in space exploration. And like the numbers are like 10 times, like for every dollar you invest in space flight, you get a 10 times return on investment. But like the answer that I just gave you, also will suffice, which is it doesn't matter. It doesn't matter. It's not, it's not like obviously there isn't a crazy amount of money spent on space exploration. It's a fraction of a penny for for people's taxes, for the amount that gets spent, for like the amount of money spent by people in various countries is very little. And yet we are learning about the universe, which is most of everything that there is, right? Like the universe is everything. We are not very much of the universe. And yet we spend most of our time down here on Earth and not very much of it trying to think about and our expenses on this entire universe that we live in. But like, I don't think that you should try to justify the practical outcome of basic research and exploration and curiosity. Because what if you're wrong? Like, we're going to develop this technology because it's going to revolutionize power generation on Earth. Well, we were wrong, and now there's no funding. I think that we are curious and that we have basic, there are different fields to be curious about in terms of biology, in chemistry, in physics, in astronomy, in neuroscience, like just everything. And that there is a certain amount of funding that should be applied at a government level, at a research level, an institutional level, to try to explore each of these basic areas to come up with an outcome. And you don't know what the result is going to be, but it is sometimes magical, it's sometimes wonderful, and changes our lives. So I think that if you're going to try to justify in a practical term the benefits that you get from space exploration or neuroscience research or any of that, that it's just a matter of time before someone goes, well, yeah, that's not worth it to me. I don't want that. I don't want that outcome. But it's really hard, I think, to stop people's fascination and curiosity about the universe that we find ourselves in. Series K Lee, how many people see UT pop up in their Google News feed now? Are you getting pennies from Lord Google? It is pennies. We are like, it's funny because I get people saying, oh, I saw your news in Google News, and that's great. You actually see probably a lot more of our stories because they're republished on other sites like phys.org and Science Alert and things like that. And that's because we do Creative Commons 4.0, so anyone can freely publish our content anywhere they want. Even for commercial purposes, go crazy. We don't care. And that's because of the patrons. We make less and less money from advertising every day. And if it wasn't for the patrons, Universe Today would not have the level of quality that we do. Like, they are literally now supporting the company. And we're close, I think, to going patron only. And there's just no sponsorship. There's no ads. There's nothing. There's just patrons supporting the work that we do so that we can report news for people. And that's really exciting. And I'm hoping to get there. I'm going to talk more about this in probably a few weeks, sort of like my big goal and what I want to try and accomplish. And if I can, then we'll just cut off all the ads entirely. And then I can just delete every ad sponsorship message that comes to my inbox, which would be cool. John Doker, off topic, but my little one had her 9th birthday this weekend. How about a quick shout out to Victoria? Hello, Victoria. You're named after the city on the bottom of my island. All right. Wait. Questions are coming in faster than I can answer them. All right. I must answer faster. We're at 7 o'clock. I gotta do a couple more, and then we'll a couple more juicy ones, and then we'll wrap it up. Here's Marie Starling. What do we know about the Andromeda Galaxy? like so much. It's a whole other galaxy. It's bigger than the Milky Way. We know quite a lot. Dragonfly Natural Power. Could you hijack an asteroid, strap on a rocket, and build a habitat on it to use it for long-distance space travel? Yes. Some really cool ideas about, an asteroid is protection from space radiation, and it's also made of stuff that you can use. And so you could subtly change the trajectory of an asteroid so that it's going on an interstellar trajectory. And then you could set up shop inside the asteroid and sort of mine it out from within while you're on your way to some other destination. And it's like one of the best ideas to sort of like, but it's, you got to be patient. It's like, you know, you're looking at tens of thousands of years to get other star systems, but it's like safer than other ways. Ganymede Melem, do you have a favorite moon? Iapetus is my favorite moon, in case you're wondering. Tim Oren, do you think humans will land on Mars? Yes, in a couple of decades. Pepper, what experiments could take place on the moon that aren't possible on the ISS? Well, the biggest question that we have right now is, what does lunar gravity do to the human body? We know that microgravity has all these effects. It causes your muscles to weaken, it causes your bones to weaken, it causes fluid redistribution in your body. But what about 1/6 gravity? Can a human being survive that? We don't know. For long term, what are going to be like? Obviously, we know that your muscles will atrophy and your bones will atrophy, but is it like, could you live there for 50 years? We don't know. Because if we could do this experiment on the moon, then it gives a much better chance of us being able to do it on Mars. Like, because the moon is worse. And so if we can go to the moon and we can survive for long periods of time, and animals can gestate and give birth on the moon, and we know that all these things are possible, then a lot of our big concerns about long-term habitation on Mars just go away. And so I actually think the moon is the best place for us to test out a more extreme version of Mars. And then if we master all that stuff on the moon, then we can go to Mars. All right, I'm going to wrap things up. Thank you, everybody, for joining me for the live show. This will be hidden after I stop this recording. So if you haven't already, you want to make sure you hang on to this. Copy paste the URL for this episode. Thank you, everybody, for asking all of the questions. What did we get through? I feel like it's 110. So I feel pretty proud of that. That was good. Thank you to John for categorizing all of those questions and putting them in the database. You are great, especially ZapFan's gone. So John, you're a hero. Everybody give a huge shout out to John, and thanks in advance to John Suffield, and thanks in advance to Chad for this mess, and Anton, you're gonna have to edit this. My work is done. All right, thanks everyone, and we'll see you all next week.